In this problem, we want to find the maximum and minimum values of the function y equals 3 cosine theta plus 5 sine theta on the interval from 0 to 2 pi. So we want to find the maximum and the minimum value. This is a closed interval, which means the max or min may occur either at the critical values or at one of those endpoints. So we're going to start by finding critical values, which means we're going to find the derivative. So y prime is equal to 3 times the derivative of cosine, which is negative sine, or negative 3 sine theta, plus 5 times the derivative of sine theta is cosine theta. So there's our derivative. Now this is going to exist for all theta because sine and cosine exist for all theta. So instead we can set it equal to 0 and solve. And to solve that equation, I think it'll be helpful if I can turn it into a single trig function instead of having two. So I'm going to move the 3 sine theta over to the right to get 5 times cosine theta equals positive 3 times sine of theta. And I want to get my sine theta and my cosine theta on the same side. At the same time, I'm going to move my 3 to the same side as the 5. The simplest way to do that is to turn this into tangent by dividing both sides by cosine theta. And I'm also going to include a 3 there. So I'm going to divide both sides by 3 times cosine theta. So on the left we'll have 5/3, and on the right we'll have tangent theta. Okay, so we need the values of theta for which tangent theta equals 5/3. You could use tangent inverse theta, and I will have to if I need to approximate my answers, but I'm going to draw a diagram first to figure out how many answers I have and where they're at. So tangent of theta is positive in 2 quadrants, the first and the third. So there's going to be those 2 quadrants, there will be one angle where tangent of theta is 5/3. Now tangent of theta is the ratio of y over x on the unit circle, or on the circle. It doesn't necessarily have to be a unit circle. So the y value is 5 and the x value is 3. So it's a little bit above a 45. So right about in there. You could have a y value of 5 and an x of 3. So that such angle is theta. And when I do solve this for theta in terms of tangent inverse, that's the one that I'm going to get. That's what tangent inverse of 5/3 is going to refer to, because tangent inverse will give you an angle between negative pi over 2 and positive pi over 2. So that is the angle also. Let's see. That particular theta there is also tangent inverse of 5/3. That's its exact value. Now to get the other corresponding value, it's going to be pi radians around, or 180 degrees around, where that y value is negative 5 and that x is negative 3, so the ratio is positive 5/3. So that angle goes all the way around like that, and it's equal to this theta, tangent inverse of 5/3, plus pi radians. So that angle, we'll call it theta as well, is equal to tangent inverse of 5/3 plus pi radians. Okay, so we have 2 tangents that solve, or 2 thetas that solve the equation tangent theta equals 5/3. You have to understand how tangent inverse works in order to understand that you need to add pi. So those are my 2 angles, and I could approximate those in the calculator, which we'll do soon. But first, let's go ahead and plug in all the values that we need. So the max and min may occur at either one of those 2 critical values or at the endpoints, 0 or 2 pi. So we need to compare the y values at those 4 values of x, meaning we need to take y at 0. Let's go ahead and do that. 3 times cosine of 0. Cosine of 0 is 1, so that's 3, plus 5 times sine of 0. Sine of 0 is 0, so y of 0 is 3. Let's take sine of tangent inverse of 5/3 let's call those theta 1 and theta 2, just to be clear. So I'm plugging in, oops, I didn't label, I'm plugging in theta 1 right now. I'm just going to scoot all of this over, since I forgot to label theta 1. There we go. So this is equal to y of theta 1. It's equal to, well, I'm not sure what I was doing there. Let's start over. It's equal to, here we go, 3 times cosine of theta. Now, I'm going to write theta 1 instead of actually writing out tangent inverse 5/3. So 3 times cosine of theta plus 5 times sine of theta 1. And I just left it as theta 1 because I can get those off this graph. If the x and y have a ratio of 3 to 5, I can use the Pythagorean Theorem real quickly to figure out the hypotenuse. Alternately, you could just round all of your answers here as decimals, but this doesn't seem too difficult to do. So to get the radius of the circle, or the hypotenuse, the leg 3 squared plus that leg 5 squared is equal to the radius squared, or the hypotenuse squared. So 9 plus 25 is equal to the square of the radius. So 9 plus 25 is 34, so the radius is the square root of 34. Or let's see, 34, I can divide that by 2 to get 17, but that's prime, so it's not going to reduce. Okay, so that information I can use to find cosine of theta and sine of theta. So cosine of theta is equal to x over r, so it's equal to 3 over root 34. So we have that 3 times 3 over root 34 plus 5 times sine of theta is the y over the r, so it would be 5 over root 34. Okay, so we have 9 over root 34 plus 5 over root 34. We already have a common denominator, and 9 plus 25 is 34. So I have 34 over root 34. If I factor the numerator into root 34 times root 34, then I can cancel one of the root 34s. And so we just get square root of 34 is the exact value. We may need the approximate value as well. So let's go ahead and compute that real quickly here. So I'm going to take the square root of 34. We get 5.83. It says round to 3 decimal places, so 5.831. Okay, now when I plug in the second theta, y of theta 2, that would actually be a lot harder to do. Well, I say that, but that's not entirely true. It would be if you tried to deal with this plus pi and you did it in that way. But actually, if we just use this triangle, this picture, right, to find cosine of theta 2 and sine of theta 2, it's not that bad. We already have the x is negative 3, the y is negative 5, and the radius is still going to be positive root 34. So we can actually find that exact value as well. So we have 3 plugging into the original function, which is right up here. We have 3 times cosine of theta 2 plus 5 times sine of theta 2. Cosine of this theta 2 is x over r, so it would be negative 3 over root 34 plus 5 times sine of theta 2. Let's put theta 2 there, that's theta 1. Theta 2 is y over r, so negative 5 over root 34. So in my first term, I've got negative 9 over root 34 minus 25 over root 34 is negative 34 over root 34. Factoring the numerator again and canceling the root 34s, I'm going to get negative root 34, which will be negative 5.831, just like that was the positive. Okay, and then last we need to plug in the other endpoint, which was 2 pi. Right here, the other endpoint of the interval. We need to plug in 2 pi into y. That would be 3 times cosine of 2 pi plus 5 times sine of 2 pi. Cosine of 2 pi is the same as cosine of 0, is 1, so it's 3. Sine of 2 pi is also, cosine of 2 pi is 1. Sine of 2 pi is 0. Okay, so the y values we're comparing are 3, 3, positive 5.831, and negative 5.831. So those are the largest values out here and the smallest values. So this would be my absolute max on that interval, and this would be my absolute min on that interval.